Hi, welcome to Module 4. Hopefully, by now, you have gotten your new workbooks. If you haven't, pause this video. You are going to need new workbooks. They are in the back of the room in the box, and we will pass a Sharpie around later so you can write your name on it. Don't take any of the other workbooks home. We'll sort that out when I get back. Today, we're going to walk through some things with decimals. We're going to do some things together. I hope that you record all of your things in your workbook that we're going to be doing on here. You can pause this video at any point, rewind, or do whatever you need to do. This will be through lessons 1 and 2.
All right, guys, before we jump into the worksheets and things, I want to kind of take a second to remind you about things you learned in 4th grade, some things we've been kind of ramping up to during our morning math minute, and other things you might have seen in Khan Academy. So the first thing I want to remind you is that when decimals come into play, and we've talked about this during our morning math minutes a lot, but when decimals come into play, anything that falls in front of the decimal this way is a whole number, a whole group, a whole something. It's where you had enough little pieces to put together and make a whole amount. Whether it's one whole amount, 100 whole amounts, or 4 million whole amounts. Anything that falls behind this decimal back in this area represents pieces that were not enough to make the whole amount. So think of it like a box of Cheerios. Over here to the left of your decimal is all the full boxes of Cheerios that you have. Everything behind the decimal is the individual Cheerios that might have spilled out and weren't able to make a box. Or maybe think of this as when you are making basketball teams and you can put 5 kids on a basketball team. Every time you get 5 kids, you're going to end up over here in front of this decimal with a whole team. But if you have kids that didn't make the team, they didn't make the cut, they're left over. They're this way. They're a part of another team that's not completed yet. Okay? We've talked a lot about that in our morning math minutes, so I just wanted to remind you. Now, I also want to talk about what happens to these numbers. We've talked about place value and how 20 is 10 times more than 2, or 450 is 10 times more than 45. So I want to talk a little bit about what happens when these numbers have decimals in them. If I gave you a number like this, 25 and 3/10. Maybe it took me 25 and 3/10 of a minute to complete this video. Now, if I made 10 videos this length, I would be saying 25 and 3/10 times 10. I would want to know how long I watched that video for. So, I know that every time I move up the place value, we're saying times 10. Oh, you really can't see that one, can you? Let's see another one. I'm saying times 10, times 10, times 10, over and over and over. So we kind of talk about that like, oh no, let's bring him to the front so you can see him. When Mario eats the mushroom, what happens to him? He gets bigger and bigger and bigger, right? So if we have our numbers here and we just multiplied times 10, I know that each place value is a multiple of 10. So I know that I would go up one place value. Well, what happens is all of these numbers also go over that place value. That 2 tens becomes 2 hundreds, 5 tens, and 3 ones, 253. Let's try another one. Okay, remember, as we're going up, we're eating the mushroom and we're multiplying. We're getting bigger. We didn't change. Mario stays Mario. He's itty bitty, and he gets bigger and bigger and bigger, but he doesn't change. He's still Mario. So if I had 89 and 421 thousandths, and I wanted to multiply that by 100. I know that 100 in my head is 10 times 10. So that tells me I'm going to go up 2 place values. So I know that everything is going to go up 2 spots. So my 8, 9, 4, 2, my decimal never ever moves. It stays right there. Now that is my new number, 8,942 and 1/10. However, not everything is awesome on Mario. He doesn't get bigger and get all the multipliers all the time. Sometimes we know he also runs into these Goombas. And when that happens, Big Mario shrinks and shrinks and shrinks. So what happens there? We're talking about division. If I started with this problem here, 89 and 2/10. And I said I wanted to split that video. It was 89 minutes and 2/10 of a minute long. I wanted to split it up evenly and watch it over 10 sessions. That means since I am dividing by 10, I now know that I'm going to go backwards. Every place value I go backwards divides by 10. So, what's going to happen to my digits? They run into... Oh, he tried to hide. They run into the Goomba. Boom, 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 boom. And they go backwards. They get smaller. So, how many place values smaller? Well, 10 tells me that it's just 1 place value smaller. So each one of them goes backwards 1. 8 and 92 hundredths.
All right, at this time, you need to go ahead and get out your new Learn book. This is your Mission or Module 4 Learn book. You're going to open up to page 5.
Okay, hopefully you have turned to page 5 in your workbook. This is a new workbook, so make sure this is not one of the workbooks you already have in your desk. This is one that hopefully our guest has passed out to you today. When we're done, you can go ahead and pass the markers around and put your name on it. And then we can just stack them up in stacks back on the calm down corner for each class so we can use them again tomorrow. Okay, we'll worry about trading out the workbooks when I come back. Please don't take any workbooks home yet. We will keep them all there for now. Okay, so the first thing that we want to look at here is complete the equations. We are on page 5. I know that if I have 1, 1, I'm going to look down here at this place value chart, and if I had 1 in my ones, I know that I could decompose that to be 10 of something else. Now, decomposing tells me that I would go that way. So it becomes 10 tenths. Think of that like a dollar. If you decomposed a dollar, you would have 10 dimes. We know that a dime, it takes 10 of those to get a dollar, so that is 1/10 of a dollar. Okay, on the next one, I have 1, 1. This time I'm decomposing it. I want 100 of something. So we already said if we move them back there, that gives us tenths. If we move them back there, that gives us hundredths. That gives me 100 hundredths. For hundredths, I hope you think of pennies, because the 100 of those makes a dollar. Now, the next one is not really a money thing that we can do, unfortunately. But we do know that if we keep dividing by a power of 10, then we go into our thousandths. And if I had pieces cut into thousandths, that means I need 1,000 of them to make one whole. Make sure you're filling these out in your workbooks. Okay, next we're going to look here and we have multiple different forms. Now, I expect that you're likely really familiar with the first two forms. 1/10 in unit form, and then we turn it into fraction form, and I expect that you're really familiar with that. Now I want you to think about if I said we had 1/10 and we put it on our place value chart. Remember, our decimals never move. They always lay right there behind our units. My tenths come right behind them. If I had 1, it would look like that. 1/10. Okay? Next we have 100th. Again, I expect that you are familiar with that in fractions. However, putting those in decimals, I would locate my hundredths, put my 1 there. I know that I cannot leave this space open, so I would need a 0. Some of you may be asking why I don't just write it like that. And the truth is you can, as long as your decimal is obvious enough that it's there. Most people, especially at 5th grade, still put a 0 in the ones just to make it obvious that you are talking about the decimals. However, not having that 0 in front of the decimal does not matter. But not having this 0 would change all of the value. Okay, let's try one more. Okay, we know that we have our decimal. We have 1/1000th. So again, we have 1 out of 1,000 pieces. Maybe you have 1 out of 1,000 Legos, and we're trying to build a whole set. So we know that when we go behind the decimal, we first break into tenths, hundredths, then thousandths. So our 1 would be in the thousandths place. I know these spots cannot be left empty, so I must put zeros there. Now, this looks a little confusing because you're not used to 1,000 having all those zeros on that side of it, or only having 2 zeros. So I want you to kind of think of the fact that the decimal line can serve a little bit like a mirror. And you're looking as you're going both ways. Some of you may be wondering, well, why couldn't I just say this is tenths and this is hundredths? Well, first of all, if I look at that, my 1 is in the same value. And I have nothing in any of the other values. As a matter of fact, I could erase those, and then I have the same exact number. So that is why the 1 is the one moving to the different value in your decimals. Okay, go ahead and turn your page over. You should be on page 7 now. We are going to look at these, and I want you to think about those base 10 blocks that we use with the little cubes and the rods and the flat pieces. So when we look at this one square, I know that this one single piece represents 1 out of how many? 10 pieces. 1/10. So how many of the units would it take to get a whole? Well, if this was a candy bar, I would need to eat how many of these to have eaten the entire whole candy bar? That's right, 10 of them, because tenths mean I need 10 to make the whole. Okay, however, you know sometimes we have unexpected guests. So the next day we have the same candy bar, but we had a lot more people show up. As a matter of fact, if I look at that 10 I had to cut that into 10 pieces. So we know altogether that we actually now have 100 pieces. So that one tiny piece is 100th of our entire candy bar. I hope these are the giant candy bars, guys. So it would take 100 of those tiny pieces to make that whole candy bar. So how many of these would you need to make the whole one? We just said it, 100. Okay, moving down to number 3. So this one right here could be a little confusing the way that it's written, because we have this big grid and we have this grid. This is just kind of like a magnifying glass that's showing you this is what's actually happening over here. It's just too tiny for you to see it. So what they did then was took all of those hundredths and split those into 10 pieces each. So you had 100 and you split each of them into 10 pieces each. That means you now have 1,000 pieces of that candy bar. That's basically a lick of the candy bar, okay? Everyone gets to lick the candy bar once. Actually, don't do that. The flu's going around, obviously. So each one piece would be 1,000th of the candy bar. How many would it take to equal the whole candy bar? 1,000. Okay, now you need to turn over to page 8. We are skipping the top part of page 8 and looking at the bottom of it. Think about your place value chips. Think about how they fit into those place value charts. We know what we talked about. If we had 1 in our ones, you can kind of draw one right here. If we had 1 in our ones, and I wanted to decompose that, it would turn into 10 copies of 1/10. So 1 is 10 times larger than 1/10. We're going to write that like this. 1 is 10 times 1/10. So if I flipped that the other way around, another way to say times 10 times larger, we flip those around and say 1/10 is 1/10 as much as 1 whole. 1/10 equals 1/10 times 1 whole. That's just using all of the language and vocabulary that we've been practicing. Flip your page over. Nope, we're still on page 9, it looks like. Here we have 1/10. We know that it takes 10 hundreds. It would take 10 pennies to equal 1 dime. So 1/10 is 10 times as large as 1/100th. 1/10 we could say is 10 copies of 1/100th. We're not being the perfect police on Miss Day's handwriting. Okay. Flip that around and we know if we're comparing 1/100th, we're saying that is 1/100th as much. Oh, I said that wrong. It's not 1/100th. It's 1/10 as much as 1/10. I'm sorry. So 1/100th is the same as saying 1/10 times 1/10. And that makes sense because if you think back to when we learned how to multiply fractions, we know that 1/10 times 1/10 would be 1/100th. Okay, on page 9, this time we're looking at 1/100th, changing it into 1/1000th. 1/100th is 10 times as much as 1,000th. Make sure you use that TH. So I know that 1/100th is the same as saying 10 copies of 1,000th. Now remember, this is a video, so if I'm going too fast, you are more than welcome to pause it. 1,000ths, we're going to flip it around now and compare, is 1/10 as much as 1/100th. So if we say 1/10 times 1/100th, we would get the same. Remember, 1/10 times 100th, the same way that we multiplied fractions, would be 1,000th. So come down here and let's look at this guy. We want to match these all together. I'm going to get out my handy dandy highlighter. 1/10 I see goes right there to 1/10 and right there to 1/10. 1,000th. I know that has to be in the thousandths place. So I'm going to look right here and connect those down there. Up here would be 1/1000th as well. 10/100ths. I want to think about this. I might even grab my place value chart to help. When I get back, I will remind you guys where those are, so you can use them as well. So 10/100ths. That tells me that I have the number 10, and that ends in the hundredths place. So 10/100ths is going to look like that. Also going to go right there. Next we have 1/100th, which goes all the way up there and right there. Okay, I want you now to turn over to page 13. We're going to continue practicing this skill just a little different. On page 13, you have the big grid and the little one beside it. Remember me telling you, these are not two separate grids. These are the same thing. This is just using a magnifying glass so that we can look really closely at one of those pieces. Because when we cut that into 1,000 pieces, they are really difficult to see. It wants us to shade the area model to represent the number. Then write the number in fraction form and decimal form. So the first thing I'm going to do is I'm going to shade 8/1000ths. I know each of these slivers is going to be 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. And I know that that goes right there in that one. So I know that I have 8 out of 1,000 pieces. If that was a fraction, it would look like that. But since it's a decimal, I know I don't have enough for a whole number. So remember, in front of that decimal, nothing. I have no tenths, no hundredths, but I do have 8/1000ths. Okay, turn your page over. We're going to look again. Now it's showing us what we have here. If you notice this time, they have 2 pieces already shaded in for us. So remember when we had those little boxes, they were worth 100. So I know that I have 2/100ths. Let me pull up my place value chart again, just so you can see it. Oh, we got to shrink it. I have 2/100ths completely full. I'm going to put that 2 in the hundredths. And I'm almost full with that next 100 piece, but I actually only have 8. That is 8/1000ths. Remember that I said we can't leave that guy empty, so we're going to fill him in with a 0. So our answer here would be 28/1000ths, which is 28 out of 1,000 pieces needed. All right. We're going to look at number 3 now. We've got a lot more filled in. When I look at this one, I could count every tiny little piece and see how many of 1,000 I have, but that seems ridiculous and really hard because I do see that some of these boxes are full. So I could count those like, well, 10, 20, 30, 40, and see how many out of 100 I have. Or I could remember that each row, each row is a tenth. And ask myself, well, I've got 1/10, 2/10, 3/10, and 4/10. So I definitely have, let's clear our place value chart here and bring it down, 4 whole tenths. So I come over here and I've got 4 of those. Now I'm going to look at these other pieces. I have 2 boxes full. Remember, we said those are hundredths. And when I look at that last one, I realized that I had 8 of the teeny tiny little slices. That gives me 400. Well, I put my 0 in the wrong spot. If you did, that's okay. That's what erasers are made for. 428 thousandths. That tells me I have 428 of the 1,000 pieces I need to make a whole piece. Okay, when I look here, it's showing me on the next page that we have 3, it looks like I'm on page 15. If you look down there, I have 3 thousandths filled in, and it wants me to write that as a decimal. Remember, if we need it, we can look at our place value chart. And I know that my thousandths place, tenths, hundredths, thousandths, is back there. Since I have 3 of those, he fits in right like that. My decimal will look like that. Whether or not I put a 0 in front of the decimal is totally up to you. Okay, moving over to page 16, we're doing the same thing. Now we have 53 thousandths. Again, we have our place value chart. And this time we have 53 pieces out of 1,000. So I know that 1,000 is my final piece here, and I've got 53 of them. I'm going to have to put a 0 in that piece, so that's going to look like that. 53 thousandths. All right. Number 3, we have 253 thousandths. It still takes 1,000 to make a whole group, and we definitely do not have that. So we have no whole numbers. But I do have 253 thousandths. Remember, whatever that denominator is, whatever unit we're saying, that is where our last digit is falling. 253 thousandths. Alrighty, we have just a couple problems left. We are now on the next page. I want you to look at these and see if we had 4 thousandths. We know that we definitely don't have a whole number because remember, nothing in front of that decimal is there. We know that we are in the thousandths place. It takes 1,000 to make a whole, and we want to write this in fraction form. We have 4 of those 1,000 pieces. Okay? On the next one, we have 14 thousandths. We had enough to make a whole group right there, which would turn into a hundredth. Imagine this is a puzzle we were building that had 1,000 pieces. We found 14 of those pieces, but to make the whole puzzle, we needed 1,000. Number 6, we're going to write this in unit form and then in decimal form. We will see how the unit form helps us make that decimal. I'm looking at my tenths and I see I have 2 of them. My hundredths, I have 4, and my thousandths, I have 1. I had no whole numbers, no ones, tens, nothing. So I have nothing in front of that decimal. Back here, I have tenths, hundredths, and thousandths. Let's move on to this chart, and this will be our last group of problems. We have 5 thousandths turned into fraction form, looks like 5 out of 1,000. We definitely don't have a whole number. We don't have any tenths or any hundredths. We just have thousandths. Okay, when I am looking here at this fraction form, I know changing it to a decimal for me, I'm going to need that 68 to be in the thousandths place. For that 8 to be the thousandths, I have to have a 0 right there in my tenths, because I didn't have enough to make any tenths. I had 600ths and 8 thousandths. Okay, fraction form. We have decimal form. We have no ones. We have no whole numbers. We have 419 out of the 1,000 pieces we need. That means we have 4/10ths, 100th, and 9 thousandths. All right, let's look at the next guy. We have 2/10ths. All right, I'm going to go ahead and put my decimal. I know I have tenths, hundredths, thousandths place value. I have 2 in my tenths and 3 in my thousandths. I cannot ignore that empty space and just squeeze those together to make 23. I have to put a 0 there. So I have 203 out of 1,000. We will work on number 10 later. I hope you guys have a great day. You can finish these up. Please work on your Khan Academy videos about adding and subtracting. And your Zern. I will be watching your GoGuardian. The chat will be open.